Hi everyone, my name is Doris Lee and I'm the CEO of Ponder. Today I'll be sharing some of the latest work we've been doing at Ponder to help data teams supercharge their data science workflow and run it at scale directly in their data warehouses. And so I wanted to start with the 10,000-foot view, which is our mission at Ponder. And our mission at Ponder is really to empower data science at scale everywhere for everyone. And the way we're doing that is by meeting users where they are, letting users stick with the Python data science tools and libraries that they know and love, but running this on whatever data infrastructure you already have on the back end, whether that's Snowflake, BigQuery, or wherever your data is living. And so what do I mean by that? Right. So let's zoom back and kind of tease apart what I mean by that. And so when we start to talk to data teams, one of the most popular one of the things that we hear a lot is that pandas is one of the most popular data science library that is out there. Now pandas is this open source data analysis tool for Python, and it's used for everything from data loading, cleaning, transformation, to doing feature engineering and so on. And people love it because of this rich and convenient set of functionalities and APIs that lets you play with your data and really work with it and get quick feedback. And so it's really a key ingredient when you're developing AI and machine learning models. And so just to kind of illustrate the prevalence and how prevalent pandas is amongst developers, this is actually data from a recent Stack Overflow survey that showed that 1 out of every 4 a developer uses pandas. And by comparisons, this is almost 5 times the number of developer using something like Spark, which is a big data tool. And again, data scientists, data teams love it because of its convenience, because it's flexible, it's expressive, it's easy to do quick prototyping and experimentation, and it's very easy to use and very intuitive. And so really, pandas is kind of the de facto language that people are using for doing data science. It's usually found in every single data organization that we've talked to, not just used by data scientists, but also data engineers, software developers, and so on even pipelines that are critical to businesses. And so now the problem comes when pandas is used on large data sets, right? So pandas is single threaded, and so things can start to get really slow when you start to operate on large data sets. What's even worse is that you can often only work on data that fits into your memory. And the moment you exceed that, you run into these like out of memory issues. And so when you actually look at the pandas documentation, the pandas official documentation, they state that pandas is simply not designed for large data sets. And so what do data teams do in this case, right? They're essentially left with these 2 options. Now, option 1 is you can go and hire a bunch of highly skilled data engineers, get them to manually rewrite these pandas workflows that have already been written into a big data framework such as Spark or SQL. And from our experience, this can take anywhere from like 3 weeks all the way up to like 6 months to translate some of these pandas workflows that you have into one of these big data frameworks. Now, option 2 is you essentially give up and resort to working with smaller data sets, but that really limits the value of the decision that you can derive from your data. So instead of looking at all your data, what you essentially have to do is you have to sample your data and look at a limited subset of your workflows. In terms of productionization, it means that most of the workflows that data science teams, machine learning teams are working on, and never end up seeing the light of day on the other end in getting productionized on the full data set. And so we see a lot of organizations with these 2 challenges in mind, simply losing out on the ability to scale out. So we can see that while pandas usage is prevalent, it actually represents a substantial dollar lost, not just in terms of developer productivity, but also the business opportunity costs. And so to address this issue of pandas scalability, over the past few years, we've developed this open source library called Modin. And you can think of Modin essentially as a faster, more scalable version of pandas. So like you see here, in order to use Modin, all you have to do is essentially change a single line of code. And so when you change the import, you can now work on much larger data sets with better performance, better scalability. With Modin, you can continue to use the same familiar Pandas API that you have, but the runtime is much faster because the operations are run in parallel. And so just a bit of context around the Modin community and the community adoption that we've seen over the past few years. So today, Modin has over 8,000 stars on GitHub and more than 6 million downloads. And Modin's adoption footprint is huge in enterprises and is being used to power AI and machine learning workflows across many industry data teams, everything from pharmaceutical companies, tech companies, even manufacturing companies, and so on. And it's also being embedded in many cloud solutions and products today, including some of the latest products from AWS. And so over the past few years, we saw that Modin is increasingly being recognized as the go-to tool for scalable data science, both for practitioners as well as tool developers. Now, as Modin was taking off and as we were working with the folks in the community, one of the things that we saw was that what data teams really needed was this ability to work with the data in their data warehouse, right? So we all know that many enterprises have already made heavy investments in their data warehouses, spending millions on Snowflake and BigQuery and so on. But they didn't necessarily want their data scientists to be pulling their data out of their data warehouse just to be able to work with their Python workflows and Pandas workflows, and have to deal with the headache of having to maintain another piece of infrastructure in their stack that doesn't have the same scalability, security, and reliability guarantees that their warehouse is providing. And so over time, people kept coming to us and ask, hey, can I run Modin directly on the data that's sitting in my data warehouse? And so after hearing this story over and over again, we invested in building this breakthrough technology that really bridges this gap between data science tools and data warehouses. And so what Ponder does is that Ponder takes Modin to the next level by letting you run Pandas directly in your data warehouse. And so for the first time in history, you get the best of both worlds. You get a fully Pandas native experience that is familiar and easy to prototype, plus the scalability, security, and reliability guarantees of operating in a modern data warehouse. And so we've actually been able to show that this technology works on up to terabytes of data with interactive latencies. And so again, this is an illustration of how Ponder works, right? What we're doing at Ponder. And so the way it works is that you take your Pandas code, you can write new Pandas code, or you have existing Pandas code that you have in production, and your data might be living in Snowflake, it might be in BigQuery, but with Ponder, you no longer have to pull your data out of your data warehouse. All the compute gets pushed directly down to the warehouse. And so your data team can now run their data science workflows at scale, all without the data leaving your warehouse. So there's no additional infrastructure setup that is necessary. And so let's take a look at a very quick demo of Ponder in action. And so what we're going to see here is a quick example of Ponder running on a healthcare data analysis scenario. And what I'm going to be looking at is I have 3 tables related to this healthcare data analysis example that is sitting in Snowflake. And so if I go into my Snowflake account, I can actually see that in the Mimic 3 database, I have 3 tables: admissions, ICU stays, and patients. So these are the 3 data sets that I'm going to be working with Ponder. And what we're going to be showing is how Ponder lets you run Pandas directly on Snowflake in your data warehouse on these 3 data sets. And so first, what I need to do is connect Ponder to Snowflake. And so it's a very simple setup. You're just connecting Ponder and Snowflake. And then after that, everything looks and feels like Pandas. So we import modin.pandas as PD. And then we use the same sort of Pandas API, pd.read SQL, to access the 2 database tables that I was talking about earlier. So ICU stays and patients. Now, the one thing to note here is that instead of pulling all of the data into memory, pulling the ICU stays and the patient's data table into memory, what we're doing here is we're just establishing a connection to these data tables. And so now, once I have these tables, right, I might want to do a join on these tables. And you can see here, again, it's the same familiar sort of pandas API df.merge, and we're joining on the subject ID column. Now, everything up to this point, the compute is actually happening directly in your warehouse. And so when I print this data frame, right, I could see that this data frame, this joined data frame, has both information from the patient's table as well as the ICU table. And so again, all of this compute is happening in the warehouse. The only snippet of data that is being pulled back is the preview, which is the top 5 rows and the bottom 5 rows that we're showing here. We can continue to do data cleaning. We can drop rows. We can drop columns and print out our data frame and really easily work with our data, just as if you're using pandas locally. Now, one of the things I love about pandas is the ability to do exploratory data analysis and get very quick insights. And one of the ways you do that is you can use things like df.describe, which takes all the quantitative values that are in your data set, for example, subject ID, expire flag, all the way up to LOS, which is length of stay. And then it computes the count, mean, percentiles, min, max, so that you can get an overview of your data set. Now, for example, if you look at that length of stay, which is LOS on this column, you can see that the average length of stay is around 4.5, all the way up to with the standard deviation being 6. So this is a very convenient way without having to write substantial amount of code to be able to get a quick overview of the data set. Now, again, with this one single line of pandas, this is actually triggering computation in the backend and running all of this computation in Snowflake directly. And just to show you that this is actually running on Snowflake, I'm going to go to the Snowflake panel and refresh my query history. You can actually see that this is the query that represents my df.describe. And instead of your data scientist or a data engineer having to write this giant long query that corresponds to describe, all you have to do is write df.describe in a single line, and it's super easy to get quick insight and move on and do other things with your data. And so this is especially great for an exploratory data analysis context. Similarly, you could do df.info and get an overview of the columns in your data set. You can also do things like date time manipulation. This is another thing that is great about pandas, is the ability to work with date time objects. I can do subtraction between date times and then compute the length of stay for a particular patient. I can compute their ages. I can even filter the data and take a look at remove any outlier entries where the age is above 100. And then finally, I can plot this result. I can plot the age that I computed and the length of stay as a scatter plot. And very quickly visualize that, hey, there's a cluster of data points here while this space is pretty sparse. And so this is an example of how you can go very quickly between working with pandas and then plotting a quick visualization with your data. Now, you saw how this is very easily done with pandas. One of the things I wanted to show is how would you actually do this in SQL, right? So just as a reference, this analysis was inspired by one of the dataset tutorials that was written by the authors at MIT. And this is actually the query that is drawn from their tutorial. So this is the SQL query, the same SQL query that you would have to write in order to do the same thing, which is I want to compute the correlation. I want to plot the correlation between age and length of stay. And so we can see that by comparison, working with pandas is relatively easy compared to having to write this SQL query from scratch. And the additional benefit of making it super seamless to plot a visualization and stay in the same analysis. Now, moving on with our analysis, here we connect to an additional table, which is the admissions table, and then we join it with our original data frame. Now, the admission table gives us some additional information about the patients and their diagnosis. So the diagnosis column is a column of free text, and it's the free text diagnosis that is assigned by the clinician. So we can see things like hepatitis B, sepsis, and so on, shortness of breath. And so one of the great things about pandas is just how easy it is to work with string data and working with text. And so what we want to do here is essentially clean up the text a little bit using pandas, but also getting a sense of what is the top 5 vocabulary or terms that is used in this corpus. And so we do some string cleaning, and then we print out what is the top 5 common diagnostic terms in this corpus. And so the top 5 is failure, sepsis, pneumonia, bleed, and acute. And so after we get that, we want to create a feature, a set of features that indicate whether a particular patient's diagnosis contain or doesn't contain that term. So so we can create each of those columns based on does the diagnosis contain or not contain. Again, this is using pandas string.contains method. And so after that, we can print out the top 5 keywords. These are the 5 new features that are created based on working with our data frame. And so now that I have this feature matrix, right, I can now do a basic machine learning training example to build a binary classification model. And the predictor that we are going to be looking at is the hospital expire flag. Now, the hospital expire flag is a binary attribute that captures whether a patient died in the hospital or not. And so that is our predictor variable. If we use the pandas value counts method, we can see that 85 records are 0, meaning that the patients didn't die. And then 42, it means that 42 records indicating that the patients did die in the hospital. So we can see that about a third of ICU patients ended up dying in the hospital. Now we want to build a binary classification model, and our X, which is our features, is the matrix which has the set of whether the diagnostic term exists or doesn't exist. So you can see that these are all binary features. And the Y is the target. The target is 0 and 1, indicating if the patient has died in the hospital. And so now we can very easily work with scikit-learn. We do a train test split, train the model. We train a naive Bayes classifier, and then we can plot the results on a confusion matrix. Now, obviously, this is a very small example, very small number of data sets. So it's mostly an illustrative example of how Ponder works together and integrates well with popular machine learning libraries such as scikit-learn. And so this is kind of the end-to-end example. So just to summarize and recap, we started off the analysis connecting to Ponder, and then after that, working with pandas natively. Everything that I showed in this example is exactly the same as what you would do if you were working with a CSV file locally. But here, all the pandas stuff is happening directly in Snowflake. Now, we saw how you can join tables, you can look at high-level summaries and overview of your data sets. You can discover insights and patterns based on visualizations and basic statistics. We saw how you can work with date time, We saw how you can work with datetime as well as creating features based on text. And then finally, work with machine learning model and build your own classification model to predict the patient mortality. Okay. So now so as we saw in the demo, Ponder lets you run your data science workflows directly in your data warehouse. So your data never has to leave your warehouse, and you can securely work with sensitive data. So for example, in our healthcare example, we were looking at PII data, patient records. These are things that you wouldn't want to leave in the close confines of your warehouse. And so you can continue to use the same Pandas APIs while getting the scalability benefits that your warehouse provides. So there's no more sort of headaches around having to maintain an additional infrastructure. Ponder essentially abstracts all of that away from you and leverages your warehouse and letting your warehouse essentially handling all of that for you. So if you're interested in trying out Ponder, you can sign up at this link here, ponder.io/product. And we really look forward to hearing from you. And thank you so much for joining the talk today.